The topic that we'll be studying and discussing today is molecules, and it's going to cover the state of matters and the kinetic theory, basically. So, what exactly is matter? We use this word matter in a lot of scientific situations, especially when we were defining mass and other scenarios when we were even talking about momentum or inertia, that mass is a measure of how much matter is in an object. Or so what exactly is matter? Well, matter is made up of tiny particles or molecules which are too small for us to see directly, but they can be seen by scientific eyes that are microscopes. And one of these is an electron microscope. Now, there are different types of microscopes, but we are talking about electron microscope because its power is pretty high and it can very easily see into or look into the inner structure or the particles of a matter or an object that is under observation. Molecules consist of even smaller particles called atoms and are in continuous motion. So, we said that matter is made up of tiny particles and that those tiny particles are molecules. So if you look around at any object around you, it is matter. It is made up of tiny particles, and those tiny particles are basically what we're referring here as molecules. So what are molecules? Well, before we get into what molecules are, it's very important to know that molecules consist of even smaller particles that are called atoms, and they are in always continuous motion, and that's really going to decide in a further discussion of how this continuous motion is important in finding out the state of matter of an object. Or even if we aren't talking about the state, then the behavior or the way a matter reacts to certain changes in its environment or something like that. So, matter is basically made up of tiny particles or molecules, and then molecules are then made up of atoms, and then atoms are in continuous motion. Let's see where we go from here. Now, as we're talking about continuous motion and also tiny particles, it's very hard to imagine that if you're looking at the solid object that's right in front of you, any solid object, it can also be your laptop or your arm or anything. It's very hard to imagine that this solid or this hard surface that's right in front of you is actually made up of very, very, very tiny particles that are not stationary and that are continuously moving. So Brownian motion is basically an experiment that is conducted to um, basically observe the continuous motion. So, what happens is that when we're setting up the apparatus for Brownian motion, the first thing that you do is that the microscope that we are going to observe, it's very important to make sure that it is adjusted properly, and the sample that or the smoke that we are going to study is right in front, and the resolution is also fine enough to examine it. The specks are smoke particles seen by reflected light. The random motion is called Brownian motion. So the specks are smoke particles, and they're seen by reflected light. Their random motion is called the Brownian motion. The little specks that we see inside when we're observing them, they are basically called they're basically governing the Brownian motion. And what happens is that there is smoke, we burn something, and then some light is thrown on it. So as it's burning the dust particles or the specks of ash or whatever the medium is, they move in random direction in air, and that really indicates how the particles are in random motion and how they're just being kicked by the air around them, which really tells us how the atoms are in continuously motion or they're continuously moving. So it is due to collisions with fast moving air molecules in the cell. Well, that's established that in that very small enclosed place, the reason why we see dust particles or particles of ash moving right or left or just in haphazard manner is because the air molecules that are in the environment, they are kicking them or they're colliding with them, which causes them to move in these random directions. A small particle is massive compared with an air molecule, but if there are more high speed molecules striking one side of it than the other at given instant, the particle will move in the direction in which there is a net force. So that basically is, just about the resultant force that if there are, because obviously air is all around us and then it's made up of molecules as we've already studied. So, um, you know, these, these molecules, they can exert forces in different direction. One molecule can hit the dust particle or the air particle in one direction, the other can do that in another direction. But the net resultant force that is being applied by each molecule will be basically will just sum them up in their directions, in their respective directions, and then you can find out the resultant force and it'll tell that in which direction is the dust particle going to move. For example, if I draw over here and we are talking about, let's just say, I take this pen and this is just a random speck of dust or whatever. So this is where we are inside. This is just very much zoomed in. This. So these are dust particles, and then the air is flung from this side, and from this side, and so and basically from everywhere. But what accounts is that you find out the resultant force, and then in that specific direction, the speck is going to move. So the imbalance and hence the direction of the net force changes rapidly and in random motion. All of those movements that are just seen continuously in this chamber, they're all because of some resultant force that is being applied to these specks as they are being observed. So again, it's just made clear that the imbalance of forces causes this haphazard random motion that we call as Brownian motion. Okay, now this is another very important topic, which is that of kinetic theory of matter. So, as well as being in continuous motion, molecules also exert strong electric forces on one another. When they are close together, the forces are both attractive and repulsive. The former hold molecules together, and the latter causes matter to resist compression. The kinetic theory can explain the existence of the solid, liquid, and gaseous states. So, like, as well as the first thing that is established is that the molecules they're in always continuous motion and they exert well the next thing is that they exert strong electric forces on one another. Now what does that exactly mean? That means that every object it's made up of atoms, and atoms has subatomic particles that have different charges on them, so they are electrically charged. So if there's an object or if there's like uh let's just say an ion, we're not talking about an atom, let's just talk about an ion. So that means that it will have some charge in it, and then the charge will attract its complementary charge and it's going to repel the same charge. So similarly, this is how it also works with atoms, that they do have they're made up of molecules, and then in further molecules have this thing that they have this charge because of the subatomic particles in them. So so when a molecule is introduced in an environment where there is another charged particle or a molecule which can complement it or complement its charge. So that really puts an impact and apply a force is being basically applied on the second molecule. So there is definitely a lot of electric forces between two molecules. They can be repulsive and they can also be attractive. So it says that the former holds molecules together and the latter causes the matter to resist compression. So that's basically what we're saying, that these forces that are exerted by the molecules, they are both attractive and repulsive. So when it's attractive, it's gonna hold them together, firm them in, and when it's the latter, then it's gonna just resist the compression. That's it. Solids. Okay. Now that we are, talking about the kinetic theory of matter, it is and the continuous motion of the tiny particles or the molecules inside of an object. Let's just get to the basic states of matter. The first state of matter that comes to our head is that of solids. So, a theory suggests that in solids, the molecules are close together and the attractive and repulsive forces between them and their neighboring ones are balanced. So what happens is that since these molecules are very fairly arranged and in a proper manner, they're not haphazard like we saw in Brownian motion. So what happens is that the imbalance of attractive and repulsive forces, because of the electric forces that we just discussed, it balances each other out. So let's just say if this was like a positive, just some charges induced at this point over in this direction, and then the negative of this one will just automatically attract, and then this side will get positive because the deficiency of the charge that was already there, but then it was shifted to one side. So that's how it basically bonds together. So this is just as if springs representing the electric forces between molecules hold the molecules together. Definitely. So this is pretty much same as the electrical forces that when the objects they are attracted to each other, or when they are complementary. So they basically attract each other, and similar is the case for springs, that it keeps them together or it holds them together. So this enables the solid to keep a definite shape and volume while still allowing the individual molecules to vibrate backwards and forward. So this arrangement of positive to negative terminals that are arranged as uh, this happens, doesn't only it doesn't only keep it in a definite shape, but it also causes or helps them to vibrate backwards, which really causes it to basically bond together. The theory about solid, it basically shows that the molecules in solid could be arranged in a regular repeating pattern like those that are formed by crystalline substances. Okay, so liquids. The theory considers that in liquids the molecules are slightly further apart than in solids. So as you could see that the in solid diagram, the layers were very much regular, and the shape of the lattice or whatever the cube it was, in which we were representing some different molecules, and whatever it was, whatever chemical it was or element it was, the thing is it was pretty much arranged. When this balance of arrangement is disruptured in one way, sorry, disrupt in one way or the other, and the molecules start sliding over one another, then basically the state that we are in is called the liquid state. So, as well as vibration, they can also same time move rapidly over short distance, slipping past one another. So, this is not completely haphazard as it's going to be for air, but this is pretty much this means that there is this low key, very slight room for the particles or these objects to slide off of the you know this image. So they are never near another molecule long enough to get trapped in a regular pattern, which would stop them from flowing and from taking the shape of the vessel containing. So it's never like they are in this place. Like even in solids, they were moving. Yes, they were moving, but still they had this perfect regular shape. That does not happen with liquids or fluids because they have to take the shape of the container. So they're constantly just moving in such a manner that they fit in together. A model to represent the liquid state can be made by covering about a third of the tilted tray with marbles and then just giving it a tilt and then shaking it to and fro, and the motion of the marble is observed. So that's basically a very good observation that you can do is that take a tray and then put some marbles or some other balls in it and then just shake it for one moment, and then you'll get it that how the other balls, they just try to slide or get in the same direction where the other molecules are. Okay, so gases. Now, as I was saying that in liquids there is some very less haphazard or sliding factor, but still it's between the layers and it's not completely has haphazard. However, in the gases, it's quite the opposite. So the molecules in gases are much further apart than solids or liquids, and so gases are much less dense and they can be basically squeezed into a smaller space. The molecules dash around at very high speed and just very randomly for air in all spaces available. It is only during the brief spells when they collide with one another and the walls of the container that the molecule force exerts. So, a model of gas is shown. The faster the vibrator works, the more of the ball bearings have collisions with the lid, a tube, and with each other, representing the gas at higher temperature. Well, this is representing gas at higher temperature, that they're haphazard, they're just colliding to one another and the walls, and they're filling the space that they are in. Okay, now basically, what are crystals? Crystals are hard, flat. Now we are done with, the states of matters. Crystals are hard, flat sides, and they have straight edges. However, there is another state of matter too, but we're not going to study that. Continuing from where I left, whatever their size, crystals of the same substance have the same shape. That it can be huge or small, but if you get a ruby or anything like that, a diamond, then it's going to be the same substance but in different shape. So this can be seen by observing through a microscope very small cubic salt crystals growing as water evaporates from the salt solution of the glass slide. The calcite crystal will split cleanly if a trimming knife. Okay, now that is just a note. Okay, the concept of diffusion. Smells, pleasant or otherwise, they just propagate in the whole air or the place that you're sitting in. What happens is that the smell or the particles of uh, that perfume or whatever that is, they propagate in form of diffusion. In diffusion, what happens is that it is like filling up space and moving to the other moving to the other part of the container or whatever. But however, in diffusion we have a gradient, and it's a more of a a proper it has a proper framework and it has proper rules that govern it. So that is that basically the diffusion happens from a region of higher concentration to a region of lower concentration. So if you're talking about the nitrogen dioxide molecules in this shape, or the diagram that is given over here, the molecules are going to travel upwards because again the gradient or the concentration of the nitrogen dioxide molecules is pretty much higher than that in the air molecules vessel. So what will happen is that in some time it will propagate upwards and it'll basically diffuse. This now these are some factors about diffusion, that the speed of diffusion of a gas molecules depends on the speed of its molecules, and it is greater for lighter molecules. So basically we know that the speed of diffusion is basically dependent on how light the molecules are and how fast the molecules are. When hydrogen surrounds the porous spot, the liquid in the U-tube moves in the direction of arrows. Well, that makes sense. This is because the lighter, faster molecules of hydrogen diffuse into the pot faster than the heavier ones or the slower ones. So the opposite happens when the carbon dioxide surrounds the pot. Well, that's very true. This is about it for this one.